In this simple circuit, we can find the current and the voltage drop across each resistor using Ohm's law. But now, take a look at this circuit. It has multiple voltage sources and loops. In this case, Ohm's law alone isn't enough to find the current and voltage across each resistor. That's when we turn to Kirchhoff's laws. Kirchhoff's current law, or KCL, is about the currents at a junction. It says that the total current entering a node is always equal to the total current leaving it. Next up is Kirchhoff's Voltage Law, or KVL. It says that if you go around any closed loop in a circuit, the sum of all voltage rises and drops is zero. Next, let's solve a simple circuit example to clearly understand how KVL works. Before moving to the example, let's understand how to assign voltage rises and drops. When current flows through a battery from low to high potential, we get a voltage rise. It means the charges gain energy. But when the current through a battery from high to low potential, it causes a voltage drop. It means the charges lose some of that energy. When the current flows through a resistor, it causes a voltage drop. Alright, let's start solving the problem. We'll assume the current flows in this direction. If that guess is wrong, don't worry, the answer will just come out negative, and the magnitude will still be correct. Now, let's apply KVL around the loop. As the current flows in the direction we assumed, there will be a 12-volt rise from the battery. Next, across the 4 ohm resistor, we get a voltage drop of 4I. Then, across the 2 ohm resistor, the drop is 2I. After that, we encounter a 5-volt drop from the opposing source. And finally, across the 6 ohm resistor, the drop is 6I. By applying KVL around the loop and solving the equation, we find the current in the circuit to be about 0.583 amperes.